Hey guys, we're in the exponent rules portion of our packet, and we're going to start with multiplying exponents. Notice here in this class example, we have two parentheses. When we have two parentheses, this means they're multiplying. And when we have variables that are multiplying that have exponents, what we do is add the exponents. And you're going to do this only with the ones that are like terms. So if we look at this class example here, I have x squared and x cubed are like terms because they both have an x. My exponents are 2 and 3, and since these x's are multiplying, we're going to add those exponents. 2 plus 3 becomes 5, so this is x to the 5th power. Then here we have our y's, also like terms. And notice this y doesn't have an exponent. Anytime something doesn't have an exponent, it has an exponent of 1. Y to the 1th and y to the 4th. We're going to add those. 1 and 4 makes 5, so this becomes y to the 5th. And that would be our final answer because x and y are not like terms. Next up is dividing. When we have variables dividing with exponents, what we are doing is subtracting the exponents. So recall from above, if we don't have an exponent, the exponent is 1, and then I'm going to do it only with the like terms. So x squared and x to the 1st. 2 minus 1 makes 1, so this becomes x to the 1st, or just x. Y to the 5th and y to the 3rd, we do 5 minus 3. That gets us 2, so y squared. And that's our final answer. Negative exponents. If we have a negative exponent, it means it is somewhere it doesn't want to be. So if it's on the bottom, it goes to the top. And becomes positive. If on the bottom, it goes to the top and becomes positive. And then likewise, if it's on the top, it goes to the bottom and becomes positive. So you can always just think about if it's negative, it doesn't like where it is, it's going to go to the opposite place. So here, a to the negative 2. Notice there's no other a's to combine it with, but I notice that here it's on the top with a negative, which means it actually wants to be in the denominator. And then once I put it there, the 2 will become positive. B to the 3rd power, since it is not negative, it's exactly where it wants to be, so we rewrite it on the top. Next, c to the negative 4, since it's in the denominator but negative, it means it wants to go to the top, and so we can rewrite it, and when we rewrite it, the exponent is positive. Same thing, d to the negative 1, it's on the denominator, so it wants to go to the top, and when it does, it becomes positive. And for that one, that would be your final answer. Next up, 0 exponents. Anything to the power of 0 is 1. So notice I have all this stuff inside parentheses and it's all raised to the 0 power. That means my final answer for this is just 1. Anything to the 0 power, doesn't matter what it is 1. Next, exponents raised to a power. This is going to be just like when we see a number outside parentheses. We need to distribute the exponent to everything and multiply. So for this kind, something that's really important is making sure we have exponents on everything if they don't. So right now I notice the 2 doesn't have an exponent, which means it's an invisible 1. Same with the x and the 3. So these all have exponents. Even if we can't see them, that exponent would be 1. Next, I'm going to take this number on the outside of the 3 and I'm going to distribute it to every single one of these exponents. And the operation we'll do is multiplying. So here, 1 times 3 is 3, so this becomes 2 to the third. Again, 1 times 3 is 3, so x to the third. On the denominator, 1 times 3 is 3, so 3 to the third. And then this y has an exponent of 2, so 2 times 3 is y to the sixth. And this right here would be your final answer unless you chose to do 2 to the third and 3 to the third in your calculator and get the actual numbers. That was Exponents. Reach out to your teachers if you have any questions.